The Paleozoic era began around 542 million years ago. It is divided into 6 geological periods, each marked by the emergence of new species of plants and animals, representing significant steps in the evolution of life. To understand this era better, we first need to describe the climatic and geological changes that occurred on our planet during this time. By the start of the Paleozoic, the Earth's major tectonic plates had already formed, laying the foundation for the continents we know today. At that time, these plates were united into 2 large landmasses, Gondwana and Laurasia. By the end of the Paleozoic, they merged into a single supercontinent known as Pangaea. The drifting of tectonic plates and ongoing volcanic activity led to the formation of many mountain ranges and the creation of substantial natural resource deposits. During this period, the rocks and minerals that people extract today from the Ural Mountains, the Altai region, Kazakhstan, Western Europe, and North America were formed. Almost all of the planet's oil, coal, and gas reserves also originated during this time. The climate of the Paleozoic era was, in many ways, similar to today's. In the early periods, it was quite warm and humid, with climatic zones showing little variation. However, as the era progressed, drier regions began to emerge, and the division of climate zones became more pronounced. This shift was partly due to the gradual increase of oxygen in the atmosphere. As plants spread across the land, they actively altered the atmospheric composition through photosynthesis. While the air at the beginning of the Paleozoic was primarily composed of nitrogen and carbon dioxide, by the end, oxygen had become one of the most important gases in the Earth's atmosphere. At the onset of the Paleozoic, the plant and animal kingdoms were not particularly diverse. By that time, algae and fungi already existed, and colonies of certain bacteria were attempting to establish themselves on land. The fauna at the end of the Proterozoic era included sponges, annelids, cnidarians, and arthropods. With the arrival of the new era, the situation changed dramatically. Over the next 300 million years, the ancestors of nearly all modern plant and animal species emerged. The first geological period of the Paleozoic era is known as the Cambrian, which ended 485 million years ago. Although all life at that time thrived underwater while the land was a lifeless desert, the beginning of this period was dubbed the Cambrian Explosion by scientists. At the onset of the Paleozoic, evolution took a giant leap forward. A vast array of diverse organisms emerged, with plant life dominated by various types of algae. These were no longer simple single-celled organisms, but rather more complex life forms with intricate structures. In periodically drying bodies of water, a new branch of terrestrial flora began to develop, the xylophytes. Eventually, these became the first plants to colonize the land. The most significant advancement in the evolution of animal life during the Cambrian period was the emergence of mollusks. These new inhabitants of the underwater world developed a crucial adaptation for the future, a protective shell or exoskeleton. This feature became one of the ways to retain moisture as life began to make its initial steps onto land. It is likely that such an exoskeleton was so advantageous in the prevailing conditions that different life forms began to independently evolve it around the same time. Some animals learned to synthesize chitin, a polysaccharide, while others extracted minerals and salts from seawater to create their protective coverings. Among the most common animals at the start of the Paleozoic era were 2 groups, archaeaceates and brachiopods. The former led a sessile lifestyle, feeding by filtering water currents. Their calcareous skeletons became the foundation for modern carbonate deposits. Brachiopods resembled today's shell-bearing mollusks, but their shells were made not of carbonates, but of phosphates. Approximately 30% of current limestone deposits are composed of these shells. The most famous representatives of Cambrian fauna were trilobites. These arthropods, somewhat akin to modern crustaceans, could grow up to half a meter in length. They had a semicircular shell and compound eyes. Among trilobites, there were both herbivorous species and scavengers. The next period is known as the Ordovician. While the general public may not know much about it, this era was marked by significant climatic and geological changes that greatly influenced the further development of life. At the beginning of the period, a hot tropical climate prevailed across the Earth. It is believed that the average air temperature hovered around 50 degrees Celsius, while ocean waters could reach up to 45 degrees. The sea level during the Ordovician is considered the highest in the planet's history. As tectonic plates continued to shift, one of the supercontinents, Laurasia, split into three parts: Siberia, the Baltic region, and Laurania. Notably, most of these landmasses were located in the southern hemisphere. North of the equator, only the supercontinent Siberia remained, along with a small portion of Laurania that would eventually become Australia and Antarctica. These continents began to drift apart, creating new oceans and altering the climate. This movement led to the formation of the Appalachian mountain range. Average air and water temperatures dropped significantly, and an ice cap began to form at the South Pole. This resulted in a decline in sea levels, changes in ocean currents, and a dramatic cooling of the climate. The end of the Ordovician period was marked by a major extinction event affecting life across the planet. However, at the beginning of this period, life in the seas and oceans was thriving. In the first 25 million years alone, a plethora of new species of sponges, algae, arthropods, echinoderms, and jawless armored fish emerged. Most importantly, the Ordovician period saw the appearance of the first vertebrate animals. The Silurian period lasted a mere 25 million years, and for almost half of that time, much of the continents were blanketed in ice and snow. The supercontinent Gondwana continued its drift towards the South Pole, while the smaller Laurania took a position near the equator. In the latter half of the period, the climate noticeably warmed. The average air temperature hovered around 25 degrees Celsius. But during this relatively short time frame, one of the most significant events in the history of life on the planet occurred. Plants and animals began to colonize the land. First, it was simple plants that evolved from coastal algae. Then, small arthropods and certain shelled mollusks ventured onto solid ground. In the water, jawed armored fish were actively developing. They already possessed a nearly complete spinal column. The emergence of jaws allowed them to change their feeding strategies and better defend themselves against predators. But for the time being, vertebrate animals were in no rush to leave the comfortable aquatic environment. Starting 419 million years ago, the Devonian period can confidently be called the Age of Fish. While vertebrates that decided to colonize the land were transforming from lobe-finned fish with gill respiration into amphibians capable of moving on land with four limbs, underwater inhabitants were developing abilities to thrive in their familiar environment. The climate on the planet remained relatively mild and comfortable throughout the period. The average air temperature didn't drop below 30 degrees Celsius. The snow and ice at the poles completely melted, and the continents Baltica and Laurania merged into Laurasia. By the end of the Devonian, they had all coalesced into the single supercontinent Pangaea. Among the vertebrate pioneers of terrestrial life, we can highlight creatures like Acanthostega and Ichthyostega. They were no longer fish, but they hadn't yet become full-fledged amphibians. The first ray-finned fish and sharks appeared in the seas, as well as armored fish, placoderms. The most prominent member of this family was the giant marine predator Dunkleosteus. The land of the Devonian period was covered in impenetrable forests consisting of tall trees, and although they didn't even remotely resemble the oaks, spruces, and aspens we're familiar with, trees of the late Devonian period had already begun to acquire primitive bark to protect their trunks and give them greater strength. Within these plants, fully formed organs were already developed, designed to transport fluids from the roots to the leaves. The following period is called the Carboniferous or Coal Age. It began roughly 360 million years ago. It was during this time that the remains of gigantic forests formed all of the world's deposits of coal and natural gas. The single continent Pangaea occupied most of the southern hemisphere and was located closer to the pole. Its subpolar zones were covered in snow, and Pangaea influenced climate processes and ocean currents. Due to the increased saturation of the atmosphere with oxygen, insects could afford to grow to enormous sizes. Some of them were the size of a modern dog. They ruled the land and skies of the Carboniferous period. The most well-known examples of gigantic insects are the giant dragonfly Meganeura and the millipede Arthropleura, which reached lengths of up to 2.5 meters. Terrestrial vertebrates evolved into full-fledged reptiles during this time. They could now live far from bodies of water and lay eggs on land. Plants continued to develop new mechanisms for conquering environments that were previously uninhabitable. During this period, they acquired seeds and were able to spread to all corners of Pangaea. The final period of the Paleozoic era is called the Permian, as the first and most significant discoveries of animal remains from that time were made near the Russian city of Perm. The continents of the Permian period remained represented by the single landmass Pangaea. The climate was similar to the previous period until near its very end. The animal world of the Permian period experienced many important developments. Firstly, synapsids and therapsids diverged from reptiles. The former became the ancestors of dinosaurs, and the latter gave rise to mammals and, in the very distant future, humans. The first synapsids externally resembled modern crocodiles or dinosaurs. Among them, we can distinguish animals such as Varanops and Dimetrodon. Popular therapsids include Gorgonops and Esteminosuchus. The development of classic amphibians also continued, with some of them taking on rather bizarre forms. As an example, we can consider a creature such as Diplocaulus. Not much is known about the marine world of the Permian period. Among the more notable representatives, we can recall the unusual fish Helicoprion with its lower jaw in the form of a circular saw. At the end of the Permian period, the most massive extinction event in the history of the planet occurred. It wiped out approximately 70% of all terrestrial and about 95% of all marine species. Scientists believe the most likely cause of this extinction was volcanic activity, which affected the composition of the atmosphere and water. After the extinction, nature once again had to begin the development of life on Earth almost from scratch. But evolutionary mechanisms are such that new animals and plants always come to replace the extinct species. Therefore, life found its way under all conditions until the end of the Paleozoic era and during subsequent geological epochs. We thank viewers for watching this video. If you're interested in this topic, you can learn more about the various animal species of the Paleozoic era and other geological periods of Earth's development from the materials on the channel. We also encourage you to subscribe to our channel and more actively express your liking through likes.